لم يلد ولم يولد ولم يكن له كفوا أحد صدق الله العظيم.
Gentlemen, thank you for the beautiful recitation. Now I would like to call Professor Dr. Tanveer Hussain to kindly come up here and welcome our guests and students and everyone. Thank you so much.
Sorry, मेरा थोड़ा कद लगता है बड़ा है, तो I need to remove this stool. Bismillahirrahmanirrahim. Honorable Chief Guest, Dr. Rana Toki Tariq Saab, this owner of Quetta Textile Mills, Kotri, and he's also the head of CPLC Sindh. Professor Dr. Khanji Harijan, Dean Faculty of Engineering. Dr. Asghar Ali Memon Saab, dear colleagues, students, ladies and gentlemen, Assalamu alaikum and good morning. It is indeed a great pleasure to welcome you again on the second day of this condition monitoring workshop. And this workshop is basically aimed at giving you the overall training and the basic knowledge of how the condition monitoring is useful for different industrial, equipments. The condition monitoring is very much important nowadays because I think if I give you some little brief of the condition monitoring, fortunately, Rana Tokir Tariq Saab, although he's owning an industry, but luckily he's also a medical doctor. तो डॉक्टर हमेशा जब भी किसी पेशेंट को हम नॉर्मली चेक करते हैं, कंडीशन चेक करते हैं, so we need to check the condition of many patients. So for that, either they use thermometer, or they use blood pressure, or some ETT or some other conditions are being taken to check the heartbeat and the blood pressure and other things. So similarly, in order to see how the person is, to see the well-being of a person, we need to check and continuously monitor the condition of the person. Similarly, in machines, we also require a continuous condition monitoring. And that continuous condition monitoring is basically very essential so that we can predict the loss of that particular machine while it has been in use for a longer time. For example, we have a particular pump. Yeah, for example, सुई साधारण गैस की जो लाइंस यहाँ से गैस को सप्लाई करें थ्रू आउट द पाकिस्तान, उनके लिए काफी सारे पंप्स इंस्टॉल्ड हैं. एंड दीज पंप्स कंप्रेसर्स आर देयर. कंप्रेसर्स जो है ये साल चलते रहते हैं. So we need to monitor the condition. And recently we have been visiting one of the sites in HQ2 Dod near Nawabshah. So the compressor failure occurred, and alternately they've got a standby compressor. So obviously the reason was, and the compressor, the main bearings were faulty, and because of that faulty bearings, the compressor was stopped, and there was a huge production loss. So for that reasons, what we need to do, we need to monitor continuously that this compressor has been running since last 4 years. Okay, so since last 4 years, what damages or what, by the passage of time, what weaknesses has occurred within the overall mechanism of the compressor. So there they installed condition monitoring for the bearing की vibration को sense करके we can check that whether the bearing is working perfectly or not. Again, there is a lubricant being used for cooling system at different locations. So we have to check the quality of lubricant, which is oil, And in that, we have to see the viscosity of oil, temperature of oil, and the contaminations. So if any of these three is giving you the value beyond its normal condition, so it will generate us alarm that the oil immediately needs changing. Okay. So similarly, in equipments, in machinery, we have the condition monitoring, which is very essential part nowadays. And without condition monitoring, it is really difficult to predict the preventive maintenance of any particular equipment. So for predicting maintenance or for preventive maintenance of equipment, the condition monitoring has nowadays been very essential part of any manufacturing or process industry. So for that particular reasons, we have got several speakers. Few of them are online. I will introduce when I'll be calling the speakers here, and few speakers will be here to give you physical talk. We have 2 keynote speeches today, and after that, all the participants will be taken to the lab for the condition monitoring workshop, which is physical hands-on experience. It'll be going on for 2 days, because yesterday we had we have workshop on LabVIEW. Yes. So on National Instrument LabVIEW. So it was very good interactive workshop, and I hope you all enjoyed a lot. So today we'll be having a specific workshop on the condition monitoring system. So I hope you'll enjoy, and I'm again very much thankful for the guests who have just come with very short notice, sir. Tokir Saab, it was really embarrassing for me just to give you a short call, and you just welcome my call. I'm again very much thankful to you, and I'm highly indebted to the Dean, Dr. Khanji Saab, for his company over here, and thank you very much. Before I call, because actually in my schedule, I was supposed to call the guest keynote speaker, Dr. Kashif Nisar. Sir Kashif Nisar Sahab, I hope you are hearing my voice. And let me take you a few moments of your time. And before we give you time to start your keynote speech, I would request Professor Dr. Khanji Harijan and along with our chief guest to come up on stage to present a souvenir. Thank you very much, sir. Now I would called the first keynote speech by Dr. Kashif Nisar. He'll be giving the keynote on Industry 4.0. And Dr. Kashif Nisar is a postdoctoral candidate and in the University of Auckland University of Technology, okay, New Zealand. He completed his PhD as a candidate with fully funding at the University Technology Petronas, Malaysia. Through his major in computer network and information technology, he has obtained solid training in research and development, writing funding proposal, journal publication, and as consultant. Currently, Dr. Nisar is serving as an associate professor at Faculty of Computing and Informatics, University of Malaysia, Sabah. And I now hand over the mic towards you, Dr. Saab. And I hope my voice is clear to you.
Okay, Bismillahirrahmanirrahim. Thanks, Professor Tanvi, for my brief introduction. Can you hear me?
Ji, आवाज आ रही.
Okay, that's great. Which means you can hear me. Everything is okay. My voice, my slides, you can see and hear.
Yes.
Okay.
Yes, sir.
Give me 1 minute. Okay, Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi wabarakatuh. And very good morning to all. Currently, I am in Malaysia, but in Pakistan, I think it's still about 10:30. We can say good morning, but in Malaysia, we have already afternoon. Okay, today, basically, my title is Future of Creativity Technologies and Industries, Empowering the IR 4.0 and IoTs as well as. Basically, you know already, we have different type of industrial revolution from IR 1 to IR 4.0. After that, we encounter with Internet 1969, Department of Defense introduced Internet. And now we have IoTs, means Internet of Things. And now another new terms, or we can say new thing, we say everything on Internet. Let's move forward. Outline of my presentation, the fourth industrial revolution and IoTs. IoTs is smart home technologies, IoT and banking 4.0, IR 4.0 in agriculture, as well as because Pakistan consider agriculture country as well as, that's why I focus about agriculture as well as, then IR 4.0 and tourism, future internet and information-centric network. Information-centric network, I can say it is an alternative internet. As you know, our current internet basically introduced only for military purposes, limited purposes. TCP IP layer, still we are using these layers. And now we have another internet, it is called information-centric network. In 2010, when Jacobson introduced this concept, and this concept basically we can communicate via centric network, name data networking, or location-based internet. So I will discuss further in detail my upcoming slides. Last but not least, conclusion. Okay, the fourth industrial revolution is coming from like end of 18th century. Like we have mechanical looms. Then in 20th century, we have assembly lines. We can make vehicles or other things on assembly line. For example, Ford Models T. And then in 1970, we started programmable logical controller or small programmings, and we can control through programmable robots as well as. Since 2010, we started Industrial Internet of Things. First time IR 4.0 introduced in World Economic Forum at Switzerland. And after that, in each country has different version of IR 4.0. Like in Japan, it is like a industrial IR 4.0 for society, and then for Korea they have forum for industrial 4.0, so on. It means in IR 4.0 automatically we introduce technologies, Internet of Things, Internet of Everything, Internet of Industrial IR 4.0. So let's move forward. Okay, what is Internet of Things? Internet of Things means our heterogeneous network can connect throughout our environment. For example, we have smart healthcare. In smart healthcare, basically our ambulance, our hospital, mobile-based application, these all connected via a heterogeneous network or Internet of Things. Then we have, of course, our smart grids, and these grids also connect with internet. Then a smart environment or smart agriculture. We can manage these things with tiny sensors, pressure sensor, motion sensor, heat sensor. In Malaysia, basically, we have two types of agriculture. One is palm oil, another is rubber trees. And these palm oils grow as date trees, very slow. That's why we can use the sensor to monitor them when they need water, when they need fertilizer, when basically this fruit ready for to plug. So these things we can use via internet or via sensors as well as. Then we have a smart home or smart city. This is also a very new concept because we need, we have in our home a smart appliance, like in kitchen, we have a microwave oven, refrigerator. In drawing room, we have a TV, air cons. We can connect these things via internet. We can control these things via Android application. And then we have a smart transportation. Already in Germany, Mercedes-Benz, they already started driverless trucks. And of course, Tesla also, they started driverless, basically smart electric vehicles. So these vehicles can connect via internet or Internet of Things, as well as operation of total US internet traffic. By 2021, we are already in 2021, 80% of global traffic will be video. Why it's video? Because now you can see we are in pandemic. In pandemic, like internet or maybe computer science or electrical engineering become like engine of our world, because without internet, basically we are disconnected due to pandemic. We cannot travel, we cannot meet physically. Some countries like in Malaysia, currently we have fully locked down. That's why our traffic, video traffic increase. And also I can say that is a normal way, but maybe I can say 80% of our global traffic will be right now video traffic. Why? Because we are nowadays using more video rather than audio. Over the network or over the phone or internet, our lightest traffic is mobile traffic, SMS, because this is the lightest traffic. Then we have audio traffic. After that, we have video and audio video traffic. That's why we need more bandwidth, more internet, high-speed internet, and that's why we need to move forward to what we say 5G. In some countries, they already started 5G. I can say 5G is 100 times faster than 4G. You can imagine then our 5G will start throughout world, then everything very fast, and we can connect easily, and we can talk, we can communicate, and telecom also almost very cheap or free. Then how to distribute video efficient in a big issues. That's another issue, because if we will use more internet, we need more security. Future internet research, basically, you can see we can use wearable devices. Currently, we are using these wearable devices. We can monitor our health. We can monitor our, what we say, body weight. We can monitor our jogging, exercise, everything, building and home automations. Of course, as I mentioned, in future, we have our house built based on the Internet of Things, like automatically lights off, maybe internet, by default internet connections, fiber optic internet connections, smart cities also. You can see nowadays we are building new cities in Malaysia. We have Cyber Jaya, that is cyber city. Everything is I can say smart city. Like they have e-meters, they have fiber optic throughout the city. They have CCTV cameras, everything. Smart manufacturing also very important because we need from end user to maybe a warehouse. Everything must be computerized. At least we can track our inventory and everything. And healthcare, because nowadays healthcare is become very important nowadays. For example, nowadays we have COVID patients. These patients, we cannot visit physically. Also, doctor unable to visit physically. That's why they can monitor these type of patients or the danger disease via online. They can control remotely, and that is very important also. After that, we have automobiles. Automobiles also very important because nowadays we are using these we have a different type of modes of transportation like trains. Then we have car and other things also. I visited Japan a few times, and I noticed that in Japan they are not using car for themselves. They are using electric train system, bullet train system. In Tokyo, if we want to visit any campus or any university, inside university we have a metro station. Then no need to use car also. So basically, these cars based on electric. So they use very less petrol car or diesel cars as well as. Today's digital technologies, basically, we have a different type of technologies like wireless sensor, filtered networks, as well as you can see here. The wireless sensors, basically, these are very cheap, very tiny, and we can use as actor and sensors, and we can use like heat sensor, motion sensor, pressure sensor in buildings, in hospitals, and in our different places to save electricity and save lives, as well as, of course, Wi-Fi. Wi-Fi is very famous. IEEE 802.11 standard. You can see IEEE is the world's biggest professional organization, more than 500,000 members throughout the world, and they have more than 2,000 standards. They already patented and recognized by us and recognized by bodies as well as. We are using Wi-Fi. Wi-Fi is everywhere, on airport, on campus, everywhere. That is also very important. Then 6 low PAN networks as well as then physical actuation world, then cyber world. And of course, in central we have Internet of Things. These connect with routers like mobile applications, web server, processing server, and internet data servers as well as. Data is very important nowadays. As much as we use more internet, more application, more things, then we have more data. And then we have more data, then it's come to data science. So data science is very important nowadays, one of the future research area. And of course, we have a smart device as well as here. Let's move forward. 9 technology pillars in IR 4.0. These are very important pillars in IR 4.0. For example, autonomous robots. These are very important. Important because in Japan, they believe on robots. They don't care immigration. They said if we have more robots, that's why we don't need human. That's why the concept is different, and also in Korea as well as. Then simulation, augmented reality. Simulation is also very important. For example, if any student or scholar want to do research, then they have 3 type of research modes. Maybe they can go for mathematical modeling, or maybe they will go for test bed, or maybe they will go for simulation. If we will go for mathematical modeling, still we need to go for test bed or maybe simulation. So that's why normally undergrad, master by research or PhD student, they focus on simulation. We have different type of simulation tools like NS2, OpNet, CallNet, MATLAB, so on. So these are near to real world. And of course, we have emulations as well as horizontal and vertical integrations. So that's very important. Industrial Internet of Things. That is also one term recently started, Industrial Internet of Things. We can use this Internet of Things in industry as well as then we can improve our quality of service, quality of product. Then cybersecurity, basically as much as we use more internet, then we need cybersecurity. For example, here in Malaysia, we always use internet banking. We trust on bank, we trust on internet. That's why we use internet banking. So if we will use internet banking, then of course we need cybersecurity. Every day, like ATM or their web page, they shut down in midnight and they maybe maintain their page or improve their page every day in 24 hours. So that's very important also. Then of course, cloud computing means nowadays everything on our cloud. Basically, for example, we are using Zoom, we are using Google Meet, we will use Messenger or Facebook, everything on cloud, in third party somewhere. We don't know basically, or sometimes we know also, or sometime we can go for a licensed cloud as well as. Basically, in future, we no need on our computer memory or hard drive because everything controlled by cloud. So recently, basically Microsoft, they already started cloud storage. No need to go for physical hard drive, everything on cloud. Adaptive manufacturing as well as we can use in Industry 4.0, then supply chain management. That is also very important from industry to warehouse to consumer, everything also involved IR 4.0. Big data analytics, data can manipulate, data can reuse, we can data mine. For example, if, long time ago, if we will go for new place and then we need to book a hotel, we will ask, normally we used to ask with our friends, those already went. Now, no need to ask them, we will go to booking.com or online application to see these hotels ranking or rating, and after that due to data mining we can recognize which hotel is best. For example, we can easily book these things due to data mining or data analytics. So that's very important. Okay. My first diagram or figure was a very basic one for layman. This one is more technical, specifically for computer science and electrical engineering students. So this one I got from ITU, International Telecommunication Unity. It is also older than the United Nations. For example, we have first industrial revolution, 18th century. Then mechanization through steam engines. We started steam engines like in British era railway. They started steam engines and steam motors and machines as well as. Then second industrial revolution, 19th and 20th century, mass production through electric energy. IEEE, as I always say, IEEE basically Edison, he came up with basically electric, and then due to this electric, basically we have a big industrial revolution. We use electric and then assembly lines as well as. Third industry revolution, late 20th century, that we already went through. Intelligent information revolution through computer and internet. Means in Pakistan, basically 90s, they started internet, end of 90s, and computer become very common to everyone. We can buy easily branded computer, second-hand, then new computer as well as. That's why this revolution is very important, and because due to computer and internet, everything become very cheap. For example, last time we used to call someone, we have to pay both sides, like Instaphone, like first G, basically without SIM. If after that GSM, then no need to pay. Then one side need to pay. After 3G, communication become very almost cheap. or now almost free. If you have internet, your communication almost free because, for example, WhatsApp. Then we have intelligent information technology, intelligent information, big data, IoT, and cloud. So these things overlap or means communicate with each other. It's, we can say, fourth industrial revolution, 21st century. The fourth industrial revolution leading the intelligent information security and digital transformation. That is very important. Now we focus on 5G or 5G, fifth generation wireless network, 280 times faster than LTE and 70 times faster than 4G. It means, nowadays you can see we have a lot of applications like TikTok, Facebook, and other YouTube. If you know how to use mobile, you can earn money. You can maybe you can use internet like Food Panda, other applications. You are boss for your own job. You can find yourself jobs due to these applications. That's why internet is very important, and mobile internet is very important. If we have 5G, means our world will be changed. Okay, the fourth industry revolution and future societies, tapping points expected to occur by 2025. 10% of people wearing cloth and reading glasses connect to the internet. For example, we have already Google Glasses. 1 trillion sensors connected to the internet. As I mentioned, sensors are very tiny, very small, and these are light emitter diode also. That's why 1 trillion sensor connected to the internet, because we can see everywhere internet. These sensors, the first robot pharmaceutic in US, the first 3D printer car in production, the first transparent of 3D printer lever, the driverless car, pulling 10% of all car on US roads, 90% of population using a smartphone. Globally, more trips journey via car sharing than in a private car. So, for example, right now we have Uber, and Uber, basically we are sharing this car. That is not a traditional taxi, but we are sharing. And the first city with more than 50,000 people and no traffic light. And these things will be happen soon by 2025. It is from World Economic Forum. This one is a Korean model, IR 4.0, key success factor in the fourth industrial revolution era. Divided into three different, I can say, horizontal pillars, like, for example, technology, industry, and society. They combine technology, industry, and society. So basically, Korean ecosystem, why they successful. I already visited a few times Korea, Hanyang University in Seoul. I learned from them. Basically, they bring everything together: family, their work, the technology, industry, society. That's why they progress or develop very fast. I believe that very fast in throughout world they develop themselves. For example, Samsung used to a grocery store. They used to sell rice. Now they transform into mobile phone. I can say world #1 mobile phone manufacturing company. And Samsung not only they are selling mobile phone, they have 40 industries. They can make from phone to ships. High intelligent information tax, high quality data infrastructure, then like providing high quality intelligent transformation tax. And meanwhile, basically they already started 5G mobile phone technology in Korea. I already tried at Seoul. Industry, basically intelligent information of whole industry. Of course, industry must be intelligent, and they depend on robotics as well as in Korea. Basically, sometimes they will proud they are near to Japan. Sometimes they proud they are near to China. So basically, for my understanding, maybe I am wrong or right, as per my experience, personal experience, they are a middle model of China and Japan. Society, flexible labor market, social safety net plus fluctuations of creative talents as well as. Then again, these things also clockwise. For example, creativity and emotions talents go to industry. Then basically intelligent information core went to again high quality data structure as well as. Impacting all aspects of value chain. Chain also very important, like blockchain and other things also. Like for example, I would like to give you an example. In basically in Nepal, they recently shared the electricity at village due to blockchain. If someone has more electricity, then they can share to their neighbor, and then share also their bill also. So these things also very important. Blockchain and sharings also, like this is a honeycomb of different type of value aspects. The industry 4.0, for example, in industry 4.0, we have, if we will say internet, then we have internet of things, internet of data, internet of people, and of course we have internet of service. So these things also combine, then we can say the industry 4.0 environment, like smart gridding, smart mobility, smart logistics, business webs, social webs, smart homes, and smart buildings as well. Workforce transformation, basically in industry. Of course, we need more graduate, and these graduate can fix to these 9 pillars of technological advancement, as I mentioned my previous slides. Then these two things, industry and technical, basically tertiary technical education also very important with traditional education. Then we can fulfill the requirement for industry and these 9 pillars. We have done some research on this Internet of Things and IR 4.0, like for example, smart home for elderly living using wireless sensor network and Android application. Basically, you know, elder people are very alone people. I think in Pakistan, maybe they live with families, but like developed countries like in Japan, Germany, and Malaysia as well, as they live old age houses. That's why they live themselves alone. That's why they need a smart home Android application, because Android phones, if I can say, throughout the world, 80% of mobile phones, basically Android phones. I'm not saying which brand, but 80% means cheap phones also Android, expensive phones also Android. Then we have about 15% iPhones and 5% unknown phones. That means these Android phones are very cheap and easily download from apps. So that's why we come up with a smart home facilities for elderly people. We can use in smart home technologies like smart CCTV camera, smart windows, smart doors, smart fire alarms. That is also very important. You can see one small sensor can detect fire, and we can save many lives due to this small sensor Internet of Things. Various type of sensors, like we have sensors data, then in between we have a database, of course, this Android application or web mobile based application, of course dynamic. Backend we have a database, front end we have interface, it is not static. Then notification and updates, Android smartphones, and of course we have a digital signals, actuators, and then it can connect to wireframe. This one is a conceptual model that is like specifically for smart home for elderly people. We have different type of like things, like those things can connect with Internet of Things, and we will use IR 4.0. These are different things we can connect to Internet of Things. This one further more line diagram of these type of sensors, how we will manage these sensors and these electronics appliance with with our smart home. Android application, that is our Android application already. Basically, we have done this application. We already implemented. Okay. After that, we have also banking 4.0. Money matter, because as much as we use more internet or more internet banking, then we need more secure internet. That is also important. Like in 1998 to 2000, we have e-banking. Normally in e-banking, we say digital bank 1.0. Then 2003 to 2008, we have multi-channel integration like digital banking. Okay, we no need to sign physically, like we can use digital banking, web-based accounts, online calculators and other things as well as. Then we have omni channels like digital banking 3.0. And here we have seamless experience, full functions, smartphone apps and clouds, click to video and other things as well as. Last but not least, we have digital banking 4.0. This one 2015 to until now present, Internet of Everything. As I mentioned, we are not talking about Internet of Things. We will talk about Internet of Everything. Nowadays, everything on Internet basically. And digital banks, digital branches, which cross channels and omni channels, in combination of all these three versions as well as future versions, internet clouds and everything as well as. And these application also we can use for banking. 30% of banking revenue potential at risk. So basically, these are some further apps. Descriptions of banking industry. These are further basically how it's worked, what type of innovation is it, is the bank game to win or loss, or so we need to change our game, like data, digital and distribution. That's very important. These confidential information, bank as well as. Okay, data is the new oil. Basically, data can manipulate, data can reuse, data mine, and we can use multiple things. Maybe you had you knew that last time a few years ago, Arab Spring came, means in Middle East and Northern Africa, and due to internet, due to Facebook, due to big data. So that's why I think nowadays data is very important. Like for example, developed countries like Canada, Australia, if you will go for immigration, they collect your data. Then they can manipulate. They can understand which type of engineer, which type of professional they need. Then they can easily bring them. So data is very important nowadays. Interaction with customers are moving quickly to mobile. Now another thing suddenly came, that is mobile internet banking or mobile internet. Now we are moving towards from desktop computer to move laptop or portable things like the laptop or notepad or other things. Now we are moving towards to mobile phone. Nowadays, we seldomly visit our laptop. We can do all things over mobile phone, Android phone, or maybe iPhone. We basically you can see here branches, call, internet, or mobile phone. So nowadays, mobile phones are more used than other things as well as. Okay, Industrial 4.0 in agriculture focus on IoT aspects. Basically, as I mentioned, Malaysia, it's not an agriculture country, but we have also here like palm oil or rubber trees. And palm oil, I believe that after Indonesia, world second number exporter for palm oil, specifically in India and Pakistan also, I think, import palm oil from Malaysia. That's why they need Internet of Things or Industry 4.0 to improve their productivity. They already use these sensors to how to measure a tree and their fruits, as well as they use drone technology, because palm oils on thousands hectares and people cannot visit physically because it's something like a jungle. So that's why they use these drones to monitor this agriculture. Same like in Pakistan, I think, especially in Sindh, we have date trees or other also agriculture products. So we can use this agriculture with IR 4.0 and using drone technology, unmanned vehicles to improve agriculture products as well as. Further, basically, we can use data insight in the future farming solution. Nowadays, we have a future farmings. No need to visit every time physically your farms. You can maybe control these things from your control room. Like past, we use these things. Now in basically we have mobile. In future, of course, we will use we have a tower and we can sit down inside our data room, that data inside, and all things connected with unmanned vehicle sensors, plant sensors. As I mentioned, we can put sensors to plant to recognize like mango trees, date trees, and connected different type of weather stations. Due to weather, we can recognize when these trees or these products need water or fertilizer, as well as this one is basically more on connecting machines and farmings. Basically, we can use and increase our productivity through this IR 4.0. Data platform enabling citizens agriculture. Now you can see here from traditional agriculture to future or current agriculture. You can see now farmer can sit down on control room. They can control, monitor different type of technology, different type of information, and machineries, fertilizer, and other things as well. Okay, now we are moving towards to basically tourism and technology. Malaysia, basically, I can say it's a tourist country because a lot of hotels, a lot of flights. I can say world cheapest airline, AirAsia, also based in Malaysia. World biggest, cheapest airline airport, also based in Kuala Lumpur, and most beautiful islands also in Malaysia. Top 10 islands in Malaysia, as well as for diving as well as. So that's why they focus on tourism, as well as in Pakistan, also very beautiful country from south to north. We have everything like desert, mountains, rocky, snow, hilly, green fields. So that's why current government focus on tourism. Why not we can focus on tourism IR 4.0 and technologies. And nowadays, due to pandemic, Malaysia focus on virtual tourism. We can do also virtual tourism as well as. I will explain in upcoming slides. Like here, you can see here we have a global middle class aging population emerging. Then we have a growth of travelers also very important, like pandemic and security, nature, disasters, and political stability. Then we have evolving visitor demand, sustainable tourism growth, travel mobility, enabling technologies. Then we have different resources and also digitalized automation, and we can use artificial intelligence, virtual reality, augmented reality, and blockchain as well as. Online platform, you can see we can use IR 4.0 and these things with online platform. Nowadays, we are dependent on too much on these things like travel information, transportation, navigation, accommodation. Now, everything on internet. If you know how to use mobile, how to use these technologies, then you can do it yourself. Okay. These are IR 4.0 tourism, basically in Han and Hotel, Tokyo. They already use robots on reception, and Yodel and New York, they have a saver robot. They can save your important things. That means they are using already robots in hotels. Then, of course, we can go for virtual reality, eye glider virtually. Then we have sky jumping. Those are afraid from real jumps. They can go for these virtual jumps also. We can use these technologies in aligned with IR 4.0. Last but not least, this diagram is basically current scenario and trends in IR 4.0 using Internet of Things like smart cities, smart environment, smart energy, smart agriculture, e-health, retail, logistic, and industrial control. So these all things become like an ecosystem of our Internet of Things. But now I can say Internet on everything. Basically everything on our internet. Just we need two things. One is electricity, another is internet. In 2000, basically 18, New Zealand government, they came up with one survey because New Zealand is basically a volcanic country. They said if something happened, disaster came, what you need first? They said we need internet, we need Wi-Fi. They don't need food because they want to connect their family. They want to inform their family they are okay, they are safe. Okay, thank you. Any question, anything? Welcome. Suggestions also welcome. Thank you. You can hear me?
Lights on कराओ, lights on कराओ. Hello, Dr. साहब, आवाज आ रही है? Can you hear us?
Yeah, Assalamu alaikum, sir. How are you?
Sam, thank you very much. It was so nice to hear more about Industry 4.0. It's very important topic. I think our young graduates, they must get benefit from what suggestions and way forward you have mentioned, and you are only one click away. You always give good response to every students, every faculty members, so they can get benefit from there. On right, Dr. Riaz, he all the way traveled from NED. He's also, we are having this joint NCRA lab, so he's PI there. So it's our joint lab. So he'll be having next talk actually after another online talk. And then we are having our chief guest here. So I would request you to stay to listen our chief guest who is from industry. We are grateful to him as well. So I don't know if there's any question from audience. Anyone would like to ask about Industry 4.0?
Guys and girls, do we have any question? If you do, raise your hand. We'll hand over the mic to you. Do we? We don't? All right. Let's move forward. Dr. Kashim Nisar, thank you so much for taking time out of your busy schedule and for honoring us with your presence today. Hope all of you liked it and have had insight how Industry 4.0 is working in Pakistan and other areas of the world. Yeah, please. Round of applause for him.
Okay, thank you.
For those of you, my pleasure.
Thank you, everyone. And thank you, Professor Bhavani Shankar. And also, thank you, Prof. Ali. I think he's sitting beside you. I can recognize. And audience, I'm very happy. Some people, they came physically here with social distance. That's good. In Malaysia, basically, we are still on full lockdown. I think in Pakistan, maybe it's partial lockdown. That is good. And keep in touch. Have a nice day. Thank you. Assalamu alaikum.
Thank you, sir. We're extremely sorry for the inconvenience occurred and the time delay earlier. For those of you who have joined us now, let me introduce myself. My name is Falakna Sumro, Assistant Manager, IEEEP. I'll be your host of the day and for the rest of the days. We feel honored to have with us the Honorable Professor Dr. Bhavani Shankar Chaudhary. Sir, you hardly need any introduction. You have made all of us proud by your distinguished work in the numerous capacities. You are one of the mentor for education services, emeritus professor and vice MUET, and all the dignitaries. Welcome. Without consuming much time, as we all know about the big data is another major issue to deal with these days. In order to let you know about this very subject, I would like to request Dr. Ashfaq Jiskani from South Korea to please give us the session. Apart from that, he's working as a research professor at National University, South Korea. His interest areas are machine learning, deep learning, big data, reinforcement learning. The related projects are IDS, IoT, and big data. Please, sir.
Hello, can you hear me? Hello?
Yes, sir, we can hear you.
Thank you. My slides are showable thing.
Yes, sir, they are quite visible.
Hello. Yes, we can see your screen, sir.
Okay, thank you. Thank you. First of all, I thank you to NCR and Professor Bhavani, and they give me the chance to speak about the big data and machine learning and IoT. And my talk is about basic stuff about the big data, machine learning, and Internet of Things, how the paradigm shift from the last 2 decades. And we will try to cover these kinds of stuff in the coming few slides. As my introduction is a short introduction, my name is Dr. Muhammad Ashfaq Jiskani, and I am basically from Hyderabad, and I am also MUET alumni, and nowadays I am working as a research professor in the Incheon National University, South Korea. And these are the contents of our presentation. We will discuss about the IoT and how does IoT works, what is the IoT, then the big data introduction, then AI stuff, and then how the big data and IoT are used in everyday life, and then AI and IoT are coupled. These technologies are used in everyday life. If you look around, you will see at least one device that have ability to connect to the internet, that can share and collect and share the data. It may be your phone, it may be your laptop, it may be your washing machine, it may be your laptop. It means each and everything nowadays connected to the internet. Nowadays, most of the time, word smart is used with the IoT, like smart home, smart watches, smart TV, and nowadays the smart home. All homes are connected with the internet, and each and everything are connected to the internet. Like you can turn on and off your lights. Nowadays, security is achieved with the IoT and AI. Why do we need IoT? It's basic to make our life more comfortable, more easiness. We are use the IoT. In the introduction of IoT, what is the IoT? Connected devices with the internet, with the internet, and this is the recent survey around about the 50 billion devices connected to the internet. Maybe you can imagine that how much devices are connected and to the internet and make our life more comfortable. And these are the few examples I mentioned here. Nowadays, the home automation, self-driving car, Tesla, telecom industry used IoT technology, automobile industry, wearable industry. In Korea, we are working nowadays on the smart city safety project of the smart city, and safety of the worker we can achieve through the wearable AI based and IoT based devices. And oil and gas industry also use the IoT, and manufacturing industry nowadays used a lot of IoT technologies. This is how the IoT work. IoT work basically on the 4 layers. It consists of the sensing device, connectivity, data processing, at the end user interface. In the sensing device, it collects the data by using the different sensor or actuator from the surrounding, and then it gives the link to the cloud by using the connectivity layer. It may be RFID or the NFC or the Bluetooth, and then the data processing. It collects collect the data, and raw data, and get the meaningful information from the raw data by using the various algorithms, by using the different smart algorithms of the AI, like the decision tree, SVM, or the any AI algorithm, to get the more meaningful result from the raw data. And at the end, the user interface. The simple example of these four layers is your refrigerator. If you can imagine, in the refrigerator, sensor, basically sense the outside temperature and what kind of item will be placed inside, and at the end you can see that the temperature on the refrigerator screen. This is basically from the front end to back end of the IoT. And nowadays, it's all about the big data. From the last 3 decades, tremendous growth of the data, which contribute to big data in terms of volume, velocity, and variety. And up to the 2020, around 44 zettabyte data is produced, which you can imagine how much data is produced per day. So it's big challenge for the researcher, and it's also nowadays a lot of hot research topic for the undergraduate student to work in this domain. It's all about the big data. It consists of the 4V: volume, data set size. It's maybe in the GBs or the zettabyte data, and then velocity, the speed in which the data is generated, then the variety and the velocity. Variety is the different form of data. It may be audio or text, and the velocity is the data trustworthiness, whether the data is the legitimate or the illegitimate. It is also a big challenge for the researcher, and specifically for the security purpose, they also focus on velocity of the data. After the big data, we will move toward the AI, why we need AI, and how does the AI work, and what types of the machine learning, and how the deep learning comes. We will discuss in the coming few slides about the AI. In a basic example of the AI is that if this is the basic scenario for the undergrad student and these kinds of students. For example, if the person is sitting here and this is the car, if the car exceeds the limit of the specific speed of the limit for the human to monitor and note down all the number is not possible. So it causes the error. If the car exceeds the specific limit, it causes the error. So to overcome these issues, we use the more advanced technology like the AI. If we use the camera there and camera capture, and it convert into the text into the specific image, and from this we can judge that which car is exceed the limit. In USA, around the 30,000 people died per year due to the road accident. So by using these kind of smart AI and IoT technologies, we can overcome these kinds of accidents. Even in Korea is one of the best country in the world. In the Korea, if you have exceed the speed of the limit, the specific speed of the limit on the road or in the highway, you can get the challan or these kinds of fine as soon as possible before you reach your destination. They have each and everything online and used AI and IoT technologies. This is the basic definition of the AI. Artificial intelligence is capability of the machine to emit the intelligent behavior. Basically, AI is accomplished by studying how the human brain thinks and how the human learns to decide and work while trying to solve the problems. And outcomes of this study used to develop the more intelligent software and system. It means the system is more intelligent and work like human. It means machine thinks like human is known as the artificial intelligence. These are the few examples that I just mentioned here, and in each example, the student can research on each example. Like image processing is a specific topic and complete field, like computer vision, speech recognition, NLP, and the self-driving car by Tesla, and the text analysis, data mining in healthcare. Nowadays, in healthcare, a lot of research is going by using AI and IoT, especially during the pandemic. COVID-19 situation. A lot of research is going by using prediction of the COVID, video gaming, and the robotics. AI is technique. This is the basically general overview of the AI, machine learning, and deep learning. AI is technique which enable the computer to mimic the human brain, human behavior. While the machine learning is the subset of the AI technique, we use the statistical method to enable the machine to improve with the experience. It means machine learn with experience without explicitly programming is known as machine learning. And deep learning is the subset of the machine learning techniques which make the computation of the multi-layer neural network feasible. And this is the Venn diagram of the AI, machine learning, and deep learning. Basically, the concept of AI is not new. It started in the 1956, and the term machine learning's first neural network terms comes in the late 80s and 90s, and at that time we don't have enough computation power. That's why the neural network was used in the late 90s and 2000 for the machine learning. And in 2006, around 2006, deep learning first coined, and the deep learning commercially available after 2010. And this is the machine learning journal we discuss here. In the machine learning, basically we have the data set, and in the data set we have to split the data into the training and testing. For example, in this example, we have the data set, the flower data set, which consists of the sepal width, sepal length, petal width, and the petal width and petal length. On the basis of this data set, first we train our machine, and then when we give the new input to this training model, it will predict whether secular or the setosa, which kind of species of the flower. It means you have the data set, you train our machine, and then when you give the new input to the your machine, your model, it will predict the new output. This is the types of machine learning: supervised, unsupervised, and the reinforcement learning. In the supervised learning, most of the time we have the classification is already done. We have the classification is already done. We have the label data. For example, in the previous slide, we have these kinds of data set, flower data set. We have already known that the flowers which have that kind of the sepal width, sepal length, petal width, and the petal. It means the classification is already done. The data set is labeled classes. This category is known as the supervised machine learning. On the basis of supervised machine learning techniques, we have the training and testing. In the training, we train our model. Then on the basis of the test data, we test our model and predict the accuracy. In the unsupervised learning, we don't have the data set is neither classified or the nor labeled. It means we don't have classifications. For example, if you are running the online store, you don't know the quality, you don't know the your customer specification. You make the classification your own self on the basis of the customer preference, which product customer like, how the customer pay, whether they pay by card or the cash, from which location customer come. It means you make the classification of your data set by your own self. There are a lot of algorithms used in the AI for the supervised technique and unsupervised. For example, in the supervised machine learning technique, you can use the decision tree, spot vector machine, logistic regression. These kinds of algorithms you used for the supervised classification, and for the unsupervised you use the KNN clustering approach. This is the reinforcement learning approach. Is the nowadays a lot of research is going in this direction. In the reinforcement learning, basically in this technique, it has the agent expose some environment, perform some action to expose some environment. If this action is true, it gets reward, and if action is not true, it may be change the state. Simple example of this case is if you have the pet dog, you trained your dog to get the newspaper from the door. If the dog get the newspaper from the door, you can reward it by chocolate. If it don't get the newspaper, you may be punished. For example, here I put the example. This is the user. If it touch the water, it may be reward. If it touch the fire, it may be punished. These kinds of on the basis of experience, accuracy is improved. This is the general overview of the machine learning, how you can categorize your problems. If your problem in the is this A or B, you can use the classification approaches. If this void, you can use the anomaly detection techniques. How much and how many you use the regression algorithms, and how this is organized, you use the in the specific categories based, you use the clustering algorithms, and what should do I next. The same example that I used in the previous slide, you use the reinforcement learning. It means it concludes your whole research direction in your upcoming futures, how you can use the AI approaches in your future. As we know that when we have already have the machine learning, AI, and IoT, why we need the deep learning? It means the few limitation of the machine learning. To overcome these limitations, we are thinking about the deep learning. AI are not useful while working with the high dimensional data that is where we have the large number of input and output. It means high dimensional data means when you have the heterogeneous data which have the large number of input and output, it is impossible or very difficult to select the specific feature as well. It is difficult and few limitation of the machine learning. That's why we are thinking the deep learning. And AI and also the machine learning can't solve the crucial AI problems and can't select the specific features. That's why we use the deep learning. One of the big challenge with the traditional machine learning model is called a feature extraction. In the statistic, we called is variables or the labels. For example, if we want to play the match outside and we think about the whether the weather is sunny or hot, but we can't think about the specific feature of the humidity that depend on the rain. It means the machine learning algorithms are not smart to extract the specific feature. These missing the important feature. To overcome these limitations, that's why we use the deep learning that extract the most of the important features. Then deep learning is a model that are coupled to focus the right feature by themselves by requiring the little guidance from the programmer. And the idea behind the deep learning algorithm is that mimic the human brain. That is the example of how the deep learning work on the biology by using implemented through the neural network. That is the biological neuron, and that is the artificial neural network. In the biological neuron, we know that it gets the input from the multiple input that is known as dendroids, and it has the central part that is the nucleus, and the output is moved through the axon terminal, and there is gap between the two axon terminal that is known as synapse, and that is the simple artificial neural network. It gets the input and weights, and that summation that get the output, that is transfer function, and gets the output. If the output is not get the proper output, it update the weight and bias by using the back propagation algorithms. This is the overview of how the deep learning, it has the multiple hidden layer, input, output, and the hidden layer. You can increase the hidden layer, you can get the better result. And the more we give in the next slide few more example. This is the computer vision example. Like we have the multiple faces. On the basis of the faces, we in the first input layer, we select the pattern, we differentiate the faces on the basis of the pattern of the local contrast. On the next hidden layer, we get the we differentiate the faces on the basis of the colors, luminosity. On the second hidden layer, we fix the specific face feature on the specific faces, and then the output. If you put the another hidden layer, you can get the more advanced result by using, if you want to select from this data set, you want to predict the number of people which have the small eyes. It means you can get the more advanced feature and you get your proper result. These are the few examples in everyday life, like the self-driving car, Tesla, voice control systems, automatic image recognition, and automatic machine translation. And these two examples in our current working project, that is with the Incheon government, with the Incheon government by Korean government and Incheon city, they are developing the smart city, and specifically they focus on the safety of their worker in their smart city. And they nowadays during the pandemic, how the worker, whether they follow the social distance of the worker or not, these kinds of working our project, as well as the how the safety can achieved by of the worker by using the whether the worker cross the danger zone or not, these kinds of our working project to achieve the safety of our worker in the smart city project. And this is the how the big data and IoT technologies are coupled and very useful not on an individual level over the society. And this is the real case. These use the various tools like the Hadoop and the GIS and the GPS and various technology like RFID tags and the sensor and the techniques like the various supervised technique like the random forest and the decision tree and the logistic regression. Basic purpose is to increase the yield and lower cost by using the different IoT algorithms, IoT technologies, and the big data and the AI techniques. Similarly, how the artificial intelligence and IoT are coupled, they are used by using the different techniques and different voice recognition systems, as well as the Amazon Echo and Hadoop and the neural network and LSTM. And nowadays, nowadays the convolutional LSTM with the convolutional neural network with the LSTM combined to select the spatial and temporal feature in these kinds of problem. These kind of problem is basically to detect the if the worker or if the industry something is happened, and how the administrator know that something is happened in your environment, and it will send the specific worker to fix that problems. And these kinds of technologies, IoT and AI, are used to achieve the best result. As we discuss in different previous slides, how does the IoT, big data, machine learning, AI stuff used? So we can conclude that IoT not only helpful for the individual, it will helpful for the society and overall for the nation. This is my presentation. Thank you very much. If you have any question, welcome.
Ladies and gentlemen, do we have any questions? If you do, raise your hand. Do we have any questions? We don't? Thank you so much, Dr. Ashfaq Jiskani, for the informative session. So do you want to say something?
Yes, I don't know whether he's online connected. Dr. Ashfaq, can you hear us?
Yes, sir. Thank you.
Okay, thank you very much. I think you are in travel. You have arrived, I think, in Islamabad or in some other city, and still you have delivered a talk. So we are highly grateful, and I think again our students, participants, they must get benefit from your talk and your experience in Korea. Because I think this is a high time that we must embark on IoT devices, applications. Being an agriculture country, it has got massive applications in saving the water or water conservation and so many other things. In addition to, of course, other industrial revolution 4.0 and all these things. So I would request students to go to your website and see what you have been doing in Korea and what are the technological trends and get benefit from this. So once again, we are grateful for your time and presentation. Thank you. And a lot of clapping for Dr.
Yes, please.
Thank you, sir. Thank you very much.
Thank you so much, Dr. Ashfaq Jiskani. I really like the way you presented your stance with the help of practical examples. That's going to help students, learn better the type of subject that you want to discuss about. Moving forward, Well-Dean William once said, "The aim of education is the knowledge, not of fact, but of values." It is an occasion like this where we get to, we get opportunities to test our knowledge and understanding regarding different subjects other than our area. In order to fulfill this desire, I would like to call Dr. Rana Toki Tariq, MD Quetta Textile Mills, to kindly come on the stage and give us a little introduction about the established company. Please, sir. He is the chief guest of the workshop today.
Bismillahirrahmanirrahim. I would like to thank you, Dr. Tanveer Saab, other respected honoraries, deans sitting in front. Now coming to the students, आप लोगों के लिए बहुत अच्छा है कि ऑनलाइन सेशंस होते हैं ताकि जो आपने बातें करनी हो आप करते रहें, अगले को पता नहीं चलता। लेकिन अनफॉर्चुनेटली मैं देख रहा हूँ तो आपको सबको तवज्जो देनी पड़ेगी। आज का ये जो टॉपिक है, कंडीशनिंग मॉनिटरिंग सिस्टम्स, दिस इज अ वेरी इंपॉर्टेंट एंड वेरी innovative for the engineering students, whether it is mechanical or electrical. Plus this pandemic ने जो पाकिस्तान के लिए काम अच्छा किया है वो ये किया है कि अगर यही कंडीशनिंग मॉनिटरिंग आप लोग कोई कंपनी ज्वाइन करते हैं और वो इसमें इस पोर्शन की इस पोर्टफोलियो आपको मिलता है, तो ये जरूरी नहीं है कि यू हैव टू बी फिजिकली प्रेजेंट एट दैट स्टेज, एट दैट country or at that engine or at that machine. You can monitor something installed in UK while sitting in Hyderabad. This is the beauty of the pandemic, जो एक तरह से हमारे थर्ड वर्ल्ड डेवलपिंग कंट्रीज के लिए जो इसने फायदा का काम किया है। जैसे डॉक्टर तनवीर साहब ने शुरू में कहा था कि आज आप डॉक्टर के पास जाते हैं तो कहता है जी अपनी शुगर लेवल भी चेक करा के लाओ, ब्लड प्रेशर भी चेक कराओ, ECG भी चेक कराओ, ये भी चेक कराओ, एंड देन आफ्टर लुकिंग एट योर रिपोर्ट्स वो डायग्नोस करता है और फिर बताता है कि यू नीड दिस मेडिसिन, यू नीड टू हैव दिस डाइट एंड एवरीथिंग। सिमिलरली दिस कंडीशनिंग मॉनिटरिंग इज exactly the same for an engineering student or an engineer towards his equipment. I would like to quote two examples. One will be of mechanical part and other will be of electrical part. In our industry, like I am running a textile unit, we have many departments. We have a power generation. So let's say power generation में अब जो setup आ गया है engines के अंदर, जैसे आपके रेलवेज के इंजन जो लोकोमोटिव के इंजन होते हैं उसमें भी मोस्टली जो आजकल आ रहे हैं उसके अंदर ये कंडीशनिंग मॉनिटरिंग का सेटअप इंक्लूडेड है। आप उसके वेयर एंड टेयर को बिफोर इट हैपेंस, हम एज एशियन प्रॉब्लम हमारे अंदर ये है कि व्हेन वी हैव अ ब्रेक डाउन, हमारी गाड़ी खराब हो जाती है, देन वी टो इट एंड टेक इट टू द वर्कशॉप। व्हाई नॉट बिफोर? द ट्रेंड इज चेंजिंग। इंजन में कोई प्रॉब्लम आ रही है, कोई मोटर है, इलेक्ट्रिकल मोटर, जब वो बस्ट हो जाती है तो हम उसको रुक जाती है, तो हम फिर उसको कहते हैं कि अच्छा स्टैंड बाय चला दो। जस्ट लाइक यू गेव द एग्जांपल ऑफ एयर कंप्रेस सुई गैस कंप्रेसिंग कंप्रेसर कि वो खराब हो गया, उनके पास स्टैंड बाय था, उन्होंने चला लिया। बट नाउ एज अ इंडस्ट्रियलिस्ट आई वुड लाइक टू टेल यू कि स्टैंड बाय का कॉन्सेप्ट खत्म होता जा रहा है। टू हैव अ स्टैंड बाय इक्विपमेंट इज कॉस्टली, यानी एक वर्किंग कंडीशन में हो, एक उसके स्टैंड बाय में हो। दिस इज ओनली आजकल जो इसका फैशन है वो हॉस्पिटल्स में 24/7 जहां पर इमरजेंसी हो, लाइफ लाइन हो, वहां वो स्टैंड बाय जरूर रखते हैं कि एक जनरेटर स्टैंड बाय होता है और एक उसका भी स्टैंड बाय होता है। बट इन आर इंडस्ट्रियल एरा, क्योंकि कॉस्ट इतनी बढ़ती जा रही है, तो अब हम स्टैंड बाय मशीन नहीं रखते। एंड टू मेक श्योर कि वो जो मशीन एक ही है और इंस्टॉल हुई हुई है, इट शुड रन 24/7
उसकी कंडीशनिंग मॉनिटरिंग बहुत जरूरी है। उसकी वाइब्रेशन सेंसर लगा होता है, वो आपको उसका ट्रेंड बताते हैं कि yesterday it was at 10, today it is at 11, tomorrow it is at like 17। तो एक इंजीनियर के दिमाग में घंटी बजनी चाहिए, something is going wrong। This is what conditioning monitoring is। इंजन्स के अंदर जो क्रैंकशाफ्ट होती है, इट्स अ वेरी क्रिटिकल पार्ट। उसके अंदर भी टेम्परेचर सेंसर्स आजकल बिल्ट इन आ रहे हैं, और उसको आप कनेक्ट कर लें, अपने मोबाइल फोन पे रख लें, कंट्रोल रूम में देख लें, वेयर एवर यू वांट टू डू इट। लेकिन उसको समझना, उसकी ट्रेंड को एनालाइज करना कि वेदर इट्स अ फॉल्स अलार्म, इट्स अ जेन्युइन अलार्म, दैट इज वेयर यू पीपल कम इन। आज एक इलेक्ट्रिकल इंजीनियर तो है, लेकिन साथ में ये जो IoTs आपने पढ़ी, इंटरनेट पढ़ी, लिटिल नॉलेज ऑफ कंप्यूटर्स, इट्स असेंशियल फॉर यू। बिकॉज वोल्ट और वाट का फर्क तो आपको आपकी स्टडीज बता देंगी, बट to link that to your PC, to your control room, to your mobile, you should have little knowledge of the computer IT। तो इसलिए इस कंडीशनिंग मॉनिटरिंग को आप ज्यादा से ज्यादा, जैसे सर ने मुझे बताया कि वी आर डूइंग अ प्रोजेक्ट फॉर पाकिस्तान रेलवेज टू मेजर द फॉल्ट इन अ ट्रैक बिफोर इट अकर्स, कि वो क्रैक कहीं डेवलप हो रहा है, पहले हेयरलाइन क्रैक है, अगर उसको केटर नहीं किया गया तो इट विल इंक्रीज, और वो फिर पूरा ट्रैक क्रैक होगा, और लाखों लोगों की लाइफ उस इंडेंजर्ड होगी। तो इस ट्रेंड मॉनिटरिंग के एनालिसिस को करना, उसको एनालाइज करना, उसको फिर प्रिवेंट करना कि जी अब इसका क्या करना है, इट्स अ न्यू कॉन्सेप्ट फॉर आवर कंट्री। इसके ऊपर मेहनत होनी चाहिए, क्योंकि बिलीव मी और नॉट, एज अ इंडस्ट्रियलिस्ट आई एम टेलिंग यू, अब वो जमाना चला गया कि व्हेन यू गो टू द पर्टिकुलर मशीन, जब वो बंद हो गई और फिर उसको देख रहे हैं कि क्या हो रहा है। अब हमारे कई इक्विपमेंट्स, अभी हमने एक इक्विपमेंट लिया है, वो इंटरनेट कनेक्ट हुआ है, और बैक एंड पे उसकी जर्मनी की वो मशीन है, तो दे हैव अ 24/7 कंप्लायंस। लेकिन अनफॉर्चुनेटली इट इज इन इंडिया। वो वहां से हमें ईमेल आ जाती है कि सम प्लीज चेक बेयरिंग नंबर 27, समथिंग इज गोइंग रॉन्ग। तो हम बिफोर कि उसमें डिजास्टर हो, बेयरिंग फेलियर हो, हम उसको देख लेते हैं। व्हाई नॉट अस, व्हाई नॉट वी, व्हाई नॉट एट मेहरान, व्हाई नॉट पाकिस्तान? तो बिकॉज आप लोगों की तवज्जो, दिस इज अ न्यू ट्रेंड। ये इसी तरह है कि जैसे पहले बारिश हो जाती थी तो हो जाती थी, लेकिन आज जो कल बारिश हुई है, हफ्ता पहले से, 15 दिन पहले से, इफ यू लुक एट कराची, वो डिजास्टर मैनेजमेंट कैंप्स भी बन रहे हैं, मीटिंग्स भी हो रही हैं, बिकॉज उनको पता है, वो कंडीशनिंग मॉनिटरिंग कर रहे हैं कि इस तारीख को इतने बजे इतने मिलीमीटर बारिश होनी है, और उनको ये भी पता है कि इतनी बारिश आएगी और निकासी जो है इसकी इतनी है। तो वी वुड हैव लाइक 8 to 16 आवर्स के ये पानी वहां से ड्रेन आउट हो। अब उसको फायदा क्या है? जो डेटा की बात की अभी एक स्लाइड में डॉक्टर काशिफ थे, आई थिंक बहुत अच्छी बात उन्होंने की कि डेटा इज जस्ट लाइक ऑयल। जैसे तेल महंगा था, सोना महंगा था, तो फ्यूचर में डेटा महंगा है। यानी अगर वो डेटा आज उनके पास है कि इतने मिलीमीटर बारिश होनी है, इतने मिलीमीटर की निकासी है, हमें 8 घंटे लगेंगे, देन चलो ये पीरियड तो हो गया, बट आने वाले कल के लिए फिर दे विल इंक्रीज एंड दे विल डेवलप दोज ड्रेन्स के बारिश हो और पानी निकल जाए। लेकिन वो तब पॉसिबल है जब आप और मैं, हम इस टेक्नोलॉजी को सीखें, इसके ऊपर अमल करें और अपनी जिंदगियों में इसको लेके आएं, तो फिर तो इसका फायदा है। अगर सिर्फ एक इंजीनियर की डिग्री लेनी है हमने और वही मेरी तरह घिसे पिटे बातें करनी है, तो फिर इस टेक्नोलॉजी का कोई फायदा नहीं है। तो डू ऑप्ट फॉर द लेटेस्ट टेक्नोलॉजी and avail this opportunity, because this will lead you to multitasking, multi jobs availability। एक आम इंजीनियर होगा और एक इंजीनियर वो होगा जिसको IoTs के बारे में पता है, जिसको कंडीशनिंग मॉनिटरिंग के बारे में पता है। ही कैन मैं उसी को जॉब दूंगा जो मेरी मशीन को बंद होने, खराब होने से पहले मुझे गाइड कर देगा कि समथिंग इज गोइंग रॉन्ग, इसका ऑयल चेंज कर दो। ऑयल की आप एग्जांपल ले लें, एक ट्रेंड है हम लोगों के यहाँ, इतने घंटे गाड़ी चलाओ ऑयल चेंज कर लो, जेन सेट्स पे आ जाता हूँ, 3000 घंटे जनरेटर चलेगा, आप उसका ऑयल चेंज कर दें। उसके अलावा आजकल ऑयल की वेस्टेज के ऊपर बहुत बातें होती है, एनवायरनमेंट की बात होती है, तो ऑयल के ट्रेंड एनालिसिस होते हैं कि इसके अंदर आप ऑयल का सैंपल लेते हैं, उसको एटॉमिक एब्जॉर्प्शन या फ्लेम फोटोमीटर पे देखते हैं कि आयरन इसके अंदर 50 ppm आ रहा है, जिंक इसके अंदर 10 ppm आ रहा है, तो जिंक कहाँ से आ रहा है ऑयल के अंदर? जाहिर बात है बिग एंड बेयरिंग या मेन बेयरिंग से स्क्रैच हो रहा है, वो जिंक उसके अंदर आ रहा है, तो आपको फौरन अलर्ट आनी चाहिए कि हाँ द बियरिंग इज वेयरिंग अप, तो आप उसका कॉज देखें क्यों हो रहा है, ऑयल के अंदर पानी तो नहीं आ रहा। तो दिस इज मल्टीटास्किंग एंड वेरी वास्ट subject, so we all should be, as a student you should be into it, learn it, and it is the only way leading forward, making you highlight कि एक आम इंजीनियर और एक ऐसा इंजीनियर जिसके पास कंडीशनिंग मॉनिटरिंग आईओटीज का एक्सपीरियंस है, डेफिनेटली उसको लोग तरजीह देंगे। तो इसी होप के साथ कि सिर्फ एम्फोसाइज है आप लोगों का कि आगे इंडस्ट्री भी जो आ रही है वो ऐसे इंजीनियर्स और ऐसे ही लोगों को हायर कर रही है जो मल्टी टास्किंग होंगे, सिर्फ इंजीनियर नहीं होंगे और बहुत कुछ भी होगा। तो लेट्स होप दिस इज एन गुड यूनिवर्सिटी एंड सिंध में इसका नाम है, let's make it popular among the world. Thank you.
Dr. Rana Toki Tariq, thank you so much for coming here, repeating the welcome of Dr. Tanvi, as he said that he called once and then Dr. Rana came here. So I really appreciated the way you took time out of your busy schedule and during just through a one call you came here. So we are really honored and proud to have you here, a generous person like you. Thank you so much, sir. Before tea break, I'll leave you with this inspiring quote by Martin Luther King. You might be knowing about him. An individual has not started living until he can rise above the narrow confines of his individualistic concerns to the broader concerns of all humanity. I would like you guys to move forward towards the canteen for lunch, for tea break. I would want you guys to stay here for a while till our guests leave for the tea break. I would like you guys to stay here for a while. All right, you guys are free to go.